Okay, here's the solution to topic question number 6, in the 1.3 topic questions. From the previous video, this should now kind of make sense to you. So I'm throwing an object up with initial velocity v naught. I could think of it using a graph like this, and I'm told that it takes, TF seconds? Yeah, so right here, it takes TF seconds to come back down. That means when it hits 0, that's half of TF, right? And as a reminder, what is it doing? It starts here at initial velocity, goes up, and then back down, hits 0, comes back down, and it's going V. The total time to do this is TF seconds. To go, that's how much time that whole movie takes. But the upward and downward journey both take half that amount of time. Which also means I could look at this graph and go, oh, down here, I must be going minus V naught from the previous video, right? I'm going down just as fast as I am going up. The negative is because it's a velocity vector, so it's downward, negative velocity. Okay, lots of different ways to solve this. They want to know, find, and I hope they said speed. Yep, speed, which is really the absolute value of my velocity at 2/3 TF. So let's just figure out, one thing we could do is go, well, how fast does it go? I mean, we just start looking at different kinds of equations and approaches, but I might just call this, I don't know if we'll need this, but in my mind I'm just going to call this, I don't know, T what? I'll just call it T1, right? So T1 is going to be 2/3, which is a little bit past half, right? T1 is about here, and I want to know how fast it's going right at that point. So I'll just call that V1. Again, I don't know if I need to use this. I'm just trying to think through the problem and go, okay, what are they really asking? I want to find this point on this line. That's what they're asking. But I have an equation for that line, don't I? I can tell you my velocity anywhere on that line. In fact, you could go y equals mx plus b if you want. I've got the b value there. I've got my slope, minus g, and it's just time. So I could say my velocity at any point in time is equal to my initial velocity minus gt. I also know that at the very bottom, after TF, I know that my V at TF is going to equal my initial, actually it's going to equal my initial velocity, isn't it? Isn't it just V naught? Negative? Wow, that's crazy. But even this value still has to obey that thing, right? So this, if this is VTF, it's also got to equal my, so this is velocity at a specific TF. But my velocity at any t, including TF, is also equal to V naught minus GT. So that's got to equal V naught minus G, but at TF. So what does that tell me? That says minus V naught has to equal V naught minus GTF. Okay, I could bring that over. The negative signs cancel, and I get GTF. So I know that this value now, or sorry, I could even solve for V naught. That's just 1/2 GTF. Right? So this guy is actually 1/2 GTF, which means, well, this is negative, but this is also 1/2 GTF. So I want to know what my velocity is at 2/3 TF. So if we go brute force, right, we'll just churn away. Well, that's going to be V naught minus G at 2/3 TF. By the way, what do they want the answer in terms of? It looks like they want velocity in terms of GTF. Well, that's good because I've got, so I'm literally trying to find this. Now, holy smokes, I've got GTF there. Well, what's V naught? V naught's that. Minus, 2/3 GTF. What's a half minus 2/3? Let's see, 6 is the common denominator. Oh, first of all, I've got G's, well, we're not really trying to isolate for anything. So let's just do the math here. I've got what, 3/6 GTF minus 4/6 GTF. So that's got to be 3/6, that's got to be minus 1/6 GTF. Okay, so that's my actual velocity. That's this value right here. I should have put V1. I told you I wasn't sure if I was going to use those as actual subscripts. But I've got, now I have my final velocity as negative 1/6 GTF. I think they're asking for speed, maybe, or magnitude. Either way, this answer is actually correct, right? I have a negative velocity. So that's how you get the answer number 6. There's another way to do it, which is to use your sensibility of this graph, right? This math is consistent with some students, and I think the solution even says, well, if I go from here to here in 1/2 TF, 2/3 TF, this point is actually 1/6 of TF, right? Because I have to go, so 2/3 is like 4/6. So a half, so just, right, a half is like 3/6. 2/3 is 4/6. So at the halfway point, if at the 3/6 point my velocity is 0, then over here I've gone 1/6 past my 0, right? So I would have increased my velocity proportionately. I don't know if that's, anyway, the canonical solution is kind of phrased in terms of that I'm 1/6 past, another 1/6 of TF from 0. That's where I am at 2/3 TF. I don't know if what I just said made sense, but if you like the math part, this makes a little bit more sense. If you're very intuitive, you might see that from the graphing standpoint and realize that 2/3 TF is really 1/6 past, in terms of time, a proportion of TF, 1/6 past the 0 point, or another 1/6 past the halfway point. Okay? All right, so there's number 6.